Okay, remember that feeling? Standing on the blacktop, chalk lines on the ground, the intense world of schoolyard handball. I mean, it seems so simple, right? But what happens when you try to teach that simple game to a seriously advanced AI? Well, that's what we're going to get into today.
It's a really good question, isn't it? We can pick up the rules in like 5 minutes, but for a computer, it's a whole different universe. You have to translate everything, our intuition, the physics of a bouncing ball, the unwritten rules of the game, into pure logical code.
Because, as it turns out, the answer is way more complex than you'd think. The journey to build a digital version of this classic game actually uncovers just how much we take for granted. So let's break down how a brand new AI tool was put to the test in, of all places, the Foursquare court. All right, so first things first, we gotta meet the tool that makes all this possible. This isn't just about writing code in the old-fashioned way. No, this is about a whole new way of working with an AI to build stuff. It's called Google Antigravity. Now, the best way to think about it is like an all-in-one command center for a developer. Instead of jumping between a bunch of different windows, your code, your AI assistant, your web browser for testing, it pulls it all together into one single smooth workspace. And this right here really shows you the difference. The old way, the developer does literally everything by hand. But with this new agent-assisted way, it's more like a partnership. You give the AI a task, and it just gets to work in the background, handling the easy stuff on its own, and then, tapping you on the shoulder when it needs your input on the trickier parts. It's like having a coding buddy who never gets tired. And here's how it all comes together. You've got the agent manager where you tell your AI what to do. Then there's the editor so you can jump in and write or tweak code right alongside it. And maybe the coolest part, the browser. The agent can actually go into the browser and test the app for you, clicking around just like a person would to make sure everything works. So you have this incredibly powerful tool. Now what? You need to give it a real challenge. Something that's fun, that we all know, but is also, well, sneakily complicated. And that's the million-dollar question, right? It's one thing to build a basic website, but can this AI-assisted approach actually handle the little details, the feeling of a fast-paced game? You guessed it. What better test than digital handball? Or Foursquare, whatever you called it. It's kind of the perfect project. We all get the concept, but the real magic is hidden in all the tiny details. And they weren't messing around with the goals here. This wasn't just going to be some clunky tech demo. The aim was for a polished game with a pro-like feel, AI that could actually play, and all those strict playground rules, all built from scratch with standard web tech. Okay, so if you're building this game, where do you start? You start with the most important thing in any ball game, the bounce. This is where you have to make the digital world feel like the real one. See, to get that pro-like feel, they couldn't just grab some off-the-shelf game engine. They had to build a custom physics engine from the ground up, which is actually a perfect job for an AI assistant. The developer could just say, hey, build me the code to make a ball bounce realistically, with the goal of making that little circle on a flat 2D screen feel like it has actual weight and height. And that meant simulating everything. You need gravity to pull the ball down, you need friction so it slows down when it rolls, restitution, that's just a fancy word for how bouncy it is, and then a really clever trick to simulate a z-axis, which creates that awesome illusion of height as the ball flies through the air. Every single one of these things has to be tuned just right. And the detail went way beyond just physics. They coded in super specific rules, like a hard 2-second limit for the top-ranked AI, the ace, to serve the ball. Just that one little rule completely changes the game. It forces a faster, more aggressive pace, and suddenly the AI feels like a real threat. Now, a realistic bounce is great, but a game's no fun without a decent opponent, right? So the next step was building an AI player that could actually, play the game. And just look at this progression. At first, the AI was just moving around randomly. Pretty dumb. So the developer gave the agent a new task: implement a return-to-center logic. Bam! Done. Then they added a mastery system so different AIs could have different skills. And finally, the best AI learned to serve strategically, aiming for the corners just like a real pro would. It's like watching a player learn and get better over time. This created this awesome ladder of opponents. You start with the jack, who's a bit clumsy, the queen knows the basics, the king is a tough defender, but the ace plays to win. Aggressive serves, smart shots. It makes the game so much more dynamic and fun. But this led them to what was probably the hardest part, the rules.
Not just the ranks, but the weird rotation logic. Like, if you get out, you go to the jack square. Simple. But what if the person in the jack square gets out? On the playground, you just kind of know what happens. But in code, you have to spell it out. And this is where that human-AI partnership is so cool. The human defines that tricky logic, and the AI agent just writes the code to make it happen.
So, what's the big deal? Well, this whole process of building a simple handball game ended up revealing something much deeper. It wasn't just about the final game. And let's be clear, the project was a huge success. I mean, this quote from the source says it all. They nailed it. They actually captured the feel of the game, creating something that felt totally authentic.
But this is the big takeaway, for me at least. The act of teaching this game to a computer forced the developers to completely pull it apart. They had to define every single thing that we just do without thinking. This slide just sums it up perfectly. The game we remember is simple, it's fun, it's intuitive. But the game they actually had to code, it's this incredibly deep system of physics, strategy, and explicit rules that you just don't see until you're forced to write it all down. So all this work led to a really fun, solid arcade prototype, which makes me wonder, now that we've seen how cool and complex this can be, is a fully developed digital handball game something you'd actually want to play? I'm genuinely curious what you all think. Drop a comment and let us know if you think this is a project worth continuing. And that kind of leaves us with one last big thought. This project used AI as a tool to build something, but along the way, it became a kind of mirror, showing us the hidden depth in something we thought was simple. It really makes you wonder, if AI can help us understand a schoolyard game on a whole new level, what other parts of our world is it going to help us see with fresh eyes?